Hello, everyone. Let me give people just a minute to show up, find the link and everything, and then we can get started. Alrighty. Hello, everyone. So I have on the screen currently for you an outline of the contents of the test. So this is exactly the questions on the test. So the first question is 3 questions of the form, here's a function, find its derivative. Some of them ask you to evaluate the derivative at a point, like find f prime of 7. Some of them ask you just to find f prime of x for some suitable x. So these should be pretty familiar. You should expect that in there there'll be a product rule question and a quotient rule question, so make sure you use the product rule on the product rule question and the quotient rule on the quotient rule question. Do note, just as a reminder, you do get one sheet of notes, so you can pick one 8.5 by 11 sheet of paper, or if you prefer, an index card. Just one sheet worth of notes that you can write whatever you want on. So, for example, all of the formulas would probably be a good idea. I will note that several people used an incorrect form of the quotient rule on the quiz, so if you did not use the correct quotient rule on the quiz, please make sure your formula sheet has the correct quotient rule / product rule before the exam on Monday. Also remember, you cannot use a calculator on the exam. There should be nothing where you need to use a calculator. Everywhere where you might want a graph has already been provided for you. So you will not need to use a calculator on the exam. So you do not have to borrow one / bring one, but even if you do, you still can't use a calculator. Okay, one question that just asks, hey, here's something, tell me the second derivative of it. So just let you practice taking a derivative, cleaning it up, and then taking the derivative again. We've done several of those in class. One question where I asked you to find the tangent line to a particular function at a particular point. On the quiz yesterday, actually, of both of the quizzes so far, finding tangent lines was the thing that the most people needed to remember how to do. So a lot of people did something that was maybe inspired by closed interval method or something, or taking derivatives and setting them equal to 0 or something. You should not be doing that for tangent lines. So make sure you know how, if you're given a function and a point, to find the tangent line. There'll be one graph question styled after those from the homework packet. So there'll be an indicated point in a graph, and based on the graph, you will have to identify what that point is, what its coordinates are. Not surprisingly at all, I think there'll be one closed interval method question and one first derivative test question. And there will be one linear approximation question. The graph question is like all the ones in the homework packet that give you a graph and say find the point labeled question mark, based on the graph, and so it will be of that style. I will wait and see if there are any other questions about what any of these question types mean. There should be ample samples of all of these types of question on both the worksheets that I posted, which if you have not looked at, remember I posted 3 worksheets on Katie that have samples of all of these types of questions, as well as the homework that you've already done to now has examples of all of these questions. Sure. So someone asks, let's go over a graph question. So I'm just going to pull one of the ones off one of the worksheets because those are what I have handy. So let's look at worksheet 2, question. Let's look at worksheet 2, question number 2C. Okay, so in this question, you are given this parabola. And so you are told that this parabola is k of x equals 8 plus 2x minus x squared. And there are 3 different points labeled. These are meant to be parallel. I think I drew them relatively parallel. And so the question is, what are the coordinates of all of these points? I'll go ahead and label the points as A, B, and C. So we can go through and look at these. So point A is the y-intercept of our function. So point A in particular has x coordinate equal to 0. And then the matching y coordinate here we get always by plugging 0 into the function. So this is going to be k of 0, which is going to be 8. So this is what we always do when we're looking for the y-intercept of a graph. The x-coordinate of the y-intercept is always 0, and then the y-coordinate is what we get by plugging in 0. Point B is actually the other way around. Point B is an x-intercept, so I don't know what this coordinate is yet, but I know that the y-coordinate is 0. And x-intercepts, remember, are a little bit trickier than y-intercepts because in order to find an x-intercept, you have to set the equation equal to 0. Okay, which I'm going to go ahead and subtract everything over to the other side just so this looks a little more familiar. Okay, so I can factor this. This factors as x minus 4 times x plus 2 equals 0. Okay, so what we see here is this function actually has 2 x-intercepts, even though they're not both present in the graph. But the other, if I think about it, if the graph continued, certainly there would be another x-intercept over here. So I have to know which one this is. But it's not a huge mystery because one of the x-intercepts has a positive x and one of them has a negative x. So that's the x equals minus 2, 1. This is the x equals 4, 1. So point B, 4, 0. Okay, so far all of this has just been pre-calculus stuff. Where I've just used knowing how to find x and y intercepts to find these 2 points. But the remaining point, point C here, sorry, I had to sneeze. Point C here, I'm going to need to use calculus to find this. Because what's special about this point C is that these 2 lines are parallel. And remember, parallel lines have the same slope. Okay. What is that slope? Well, because I know point A and point B, I can figure out what that slope is. Namely, that slope is 8 minus 0 divided by 0 minus 4. So this common slope that both of these lines have is minus 2. Okay. So what's special about the point C? What's special about the point C is that at C, the tangent line has slope -2. So at C, the derivative is -2. Sorry, not f prime, k prime. So to figure out what point C is, I need to actually take the derivative and set the derivative equal to -2. Okay. So the derivative in this case is k prime of x equals 2 minus 2x. I'll set this equal to 0. And when I solve that, I'll get x equals 1. Okay. And so that means C is 1, comma, and then I need to get the y-coordinate. And so the y-coordinate here I get by plugging this x back into the original function. And definitely remember, I need to plug the x back into the original function to get the y-coordinate of the point on the graph, not into the derivative. Okay, but when I do that, I get 8 plus 2 minus 1, which is 9. And so that means C is the point 1, 9. Okay, so those are the 3 points, 0, 8, 4, 0, 1, 9. So that is the kind of thing that you'll be asked in a graph question. And you'll just have to identify from the graph, am I being asked for an x-intercept? Am I being asked for a y-intercept? Am I being asked for a place where the derivative is something particular, etc.? You can figure this out, and we have lots of sort of samples of these throughout. Any questions about this question and my solution to it, or other questions? Anything from the worksheets or the homework that people want to go over? Anything you want to review, or just, I want another example of blank, 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 whatever. For example, 12C. Let's see, 12C. 1 second, I have a lot of things up. There we go, 12C. So I'm not quite sure what you mean by can you just simplify it. You certainly have to take the derivative, but you can certainly simplify it first. So for example, for 12C, there's 2 different approaches to 12C. So 12C gives you that h of x is 1 over x times e to the x, and then asks you to find the derivative. And there's 2 sorts of ways. One is the just do it way, which is to say, okay, the numerator here is 1, the denominator is x times e to the x. So the derivative here is 0, and the derivative here, and here I need the product rule because I have a product. So I sort of enter into subproblem land, where I'm now doing a product rule question where the product is between x and e to the x. So a prime is 1, b prime is e to the x, and so the derivative of x times e to the x is, okay, so it is a prime b plus ab prime, which is x plus 1 times e to the x. And so that's answer from the subproblem feeds back into your original problem. And now I can apply the quotient rule here, which when I do, I'm going to get that h prime of x is a prime b minus, and then ab prime. Now be super careful in these instances where you're multiplying something by 0. 0 times anything is just 0. So this whole thing just evaporates. We don't just get rid of the 0. It gets rid of the entire term. And so this is minus x plus 1 divided by e to the x squared. Sorry, there is a times e to the x. Now I have an e to the x in the numerator and 2 e to the x's in the denominator, so I can cancel one of them and get that, which is the answer. Now, I think what you may have been alluding to in the chat is that there's a different way to do this, which is to first rewrite what h of x is. So nothing wrong with this solution we just did, but I could equally well have said, okay, well, h of x, I could, instead of writing it as 1 over x times e to the x, I could instead have written it as x to the minus 1 over e to the x, which has the bonus that when I go to write this down now using the quotient rule, it ends up working out like this. Okay, and in particular, I don't need to do an extra product rule. So you can finish the problem from here. But the point is, yes, you can absolutely rewrite the thing you're asked to take the derivative of in any way you want before you take the derivative, and often it is quite wise to do so. Okay. Rebecca, if that did not answer your question, let me know. I think that's what you were asking, but if you wanted something else, just feel free to ask. In the meantime, let's hop on over to talk about 1C from worksheet 1. Okay, which gives you k of x is x to the e plus e to the x plus x over e plus e over x. Okay. And we want to find k prime of e. Okay, so here's one where I think it helps an awful lot to rewrite a lot of this before we start. So let's write x to the e plus e to the x. This is it will help me to write this as 1 over e times x plus, and then this it will help me to write as e times 1 over x. Okay. Now, the important thing to remember about e is that e is a number, so it's a constant, and so you can treat e basically exactly like you would treat the number 3. So when I go to take the derivative of x to the e, well, if it were x cubed, I would just subtract 1 from the 3 and put it in front. So I do the same thing with e. So this is e times x to the e minus 1 plus, this is e to the x, whose derivative is just e to the x, plus, okay, now this is just a number times x, so when I take the derivative, I'm going to get 1 over e times the derivative of x, but the derivative of x is just 1, plus, and now e times the derivative of 1 over x. And so if you liked the formula I gave you for the derivative of 1 over x, it'll be times minus 1 over x squared. Okay. And so k prime of x here works out to be e times x to the e minus 1 plus e to the x plus 1 over e, or e to the minus 1, I guess I'll write it as minus e over x squared. Okay. But then, surprise, we get to plug in e and then do a bunch of simplification. So k prime of e is now going to be e times e to the e minus 1 plus e to the e plus e to the minus 1 minus e over e squared. Okay, so now I have to think about my properties of exponents. So e times e to the e minus 1. This is an e to the first power times an e to the e minus first power. When I multiply things with like bases, remember I add the exponents. So because these are both e, I can rewrite this as e to the e minus 1 plus 1. And e minus 1 plus 1 is e. Plus, this is e to the e. Plus, it's e to the minus 1 minus. Now this is an e to the first divided by an e squared, so that because of the way fractions work, I end up subtracting the power of 2 in the denominator from the power of 1 in the numerator. So that becomes a minus e to the minus 1. Okay. So these two terms actually cancel, and I'm left with 2 times e to the e. I will give a minute for questions about that before I talk about 16D. Yeah, I like this one. Just the way everything works out and cancels, and it ends up being way nicer than you would think. It is a longtime favorite of mine. Okay, so for 16D, we are asked about the intervals of increasing and decreasing and the local mins and maxes. Oh, sorry, no, we're just asked about intervals of increasing and decreasing for the function k of t equals t squared times the natural log of t. Okay, so first step, we have to find the derivative and then set it equal to 0. So here I will write a equals t squared, b is the natural log of t, a prime is 2t, b prime is 1 over t, and then we multiply these a prime b is 2t times the natural log of t, plus, then ab prime is t squared times 1 over t, which is just t. And so now I want to know when this is 0. Okay, and so here factoring is our friend. So I'm going to factor a t out of this. Okay. So I have a product of two things being equal to 0. This is going to give me a t equals 0. That's going to turn out to not really be a solution, but we'll see that in a second. Okay, here I need to solve 2 times the natural log of t plus 1 is equal to 0. So 2 times the natural log of t is minus 1. So the natural log of t is minus a half. And depending on exactly how you like to think about this, you can either say, okay, what is the number whose natural log is minus a half? Well, certainly the number whose natural log is minus a half is e to the minus 1/2 power. Or you might have been trained that if you're faced with this kind of equation, you sort of stick an e here and an e here, and then the e to the natural log of t cancels, and you're left with a t equals e to the minus 1/2. Either of those ways, or some mixture of both, will get you there. Okay. So I ostensibly got two critical numbers, one at t equals 0 and one at t equals e to the minus 1/2. Okay. So I get to make up my number line. Okay. And I'll go ahead and put t equals 0 on it and e to the minus 1/2 on it. Okay. Now, this does require you to remember that e to the minus 1/2 is still positive, because e to everything is positive, which is why this is to the right of 0. Okay. And I need to pick some test points here. So this number is significantly less than 1, so I can pick 1 as my test point over here. Remember, I know that because e to the minus 1/2 is 1 over the square root of e. The square root of e is bigger than 1, so 1 over the square root of e is less than 1. Now, on the other hand, I can pick e to the minus 1 here. And you can pick whatever you want over here, but now is maybe a good time to make an observation, which is that if you look at the graph, you might notice, if you ask what's happening to the graph to the left of 0, the answer is there isn't a graph to the left of 0. Okay. And that's because, in fact, actually the function is undefined in this whole area over here. Okay. Now, there's a couple clues to that. One clue is that the graph I gave you stops at 0. The other clue is that if you think about what would happen if I plugged a negative number into this function, I would be plugging a negative number into natural log, and natural log, in fact, only accepts positive inputs. Natural log of 0 and natural log of negative numbers are both undefined. Okay. So, in fact, I only have to concern myself with 2 intervals. The one where it is bigger than e to the minus 1/2, and the one where it is between 0 and e to the minus 1/2. Okay, so let's remember, over here, this was our derivative. Okay. So what is k prime of 1? Well, k prime of 1, I'm going to get by plugging 1 in here, which is going to be 1 times twice the natural log of 0 plus 1. Sorry, 1 times twice the natural log of 1 plus 1. The natural log of 1, though, is 0. So this is ultimately 1, which is positive. Okay. Now, over here, I need to plug in e to the minus 1, where I'm going to get that k prime of e to the minus 1, that's going to be e to the minus 1 times twice the natural log of e to the minus 1, which is minus 1, plus 1. Okay. 2 times minus 1 is minus 2, plus 1 is minus 1. So this is a minus e to the minus 1. Okay. But as messy as that is, the only thing I care about is this minus. So here it is negative. And thus we get as our answer that this function is increasing from e to the minus 1/2 to infinity, and it is decreasing from 0 to e to the minus 1/2. Now, you should definitely look at the graph and see if the graph agrees with this. Okay. And when you look at the graph, you will see the graph stops at 0, so you'll see that part which we mentioned before. You'll see there's one point in the middle where the graph changes from decreasing to increasing. So that's good, because it was decreasing first and then increasing. And we'll see that that point is a little less than 1. And so, indeed, e to the minus 1/2 would work with that. And so I have exactly described here a function which is undefined for negative inputs, then decreasing for the first bit, and then increasing afterwards. So this matches the graph perfectly. So that makes me happy and makes me confident that things have gone correctly. Any questions about this or other questions? Yeah, I can write out k prime of e to the minus 1. So let's write that out in slow motion. So k prime of e to the minus 1 is e to the minus 1 times 2 times the natural log of e to the minus 1 plus 1, which is e to the minus 1 times 2 times the natural log of e to the minus 1 is minus 1 plus 1. So that is e to the minus 1 times, and then that is minus 1. And so that is minus e to the minus 1. Okay, I will do worksheet 2, number 1. Oh, 1C, okay. Sheet 2. Oops. 1C. Wait. Didn't I already do worksheet 2, 1C? Sorry, I'm looking at the wrong thing. Okay. Worksheet 2, 1C. Okay. I was looking at worksheet 1. Different worksheet. Okay. So, 1C worksheet 2. So here we have k of x is equal to e to the 4th plus the square root of x times e to the x. Okay, when we want the equation of the tangent line at 4, 3 e to the 4th. Okay, so let's first find the derivative. Okay. And the first thing we need to notice right away is that e to the 4th is a constant, and so its derivative is 0. Okay. And so when I take this derivative, that piece just drops off, and I end up really taking the derivative of the square root of x times e to the x. Okay, so when I go ahead and write this out, a is the square root of x, b is e to the x. A prime is 1 over twice the square root of x. B prime is e to the x. So k prime of x is a prime b, which is to say it is e to the x divided by 2 root x, plus ab prime, so that is square root of x times e to the x. And having found the derivative, I now want to go ahead and plug in the x-coordinate of the point where I want the tangent line, because the derivative is going to tell me the slope. So the slope of the line I'm looking for is k prime of 4. And that 4 is this 4 that is getting plugged in. Okay, so this is e to the 4th divided by twice the square root of e to the 4th plus the square root of 4 times e to the 4th. Okay, so this is e to the 4th divided by 2e squared plus 2e to the 4th. Oh, I plugged in the wrong number. I was like, this is not going to get me the right answer. Here I plugged in e to the 4th for x. I was not supposed to plug in e to the 4th for x because e to the 4th is not my x. 4 is my x. So rewind. M here is now, okay, so this is e to the 4th divided by 2 times the square root of 4, which is 2, plus 2 times e to the 4th. Okay. So this is e to the 4th over 4 plus 2e to the 4th. Okay. which is e to the fourth over 4 plus 8 over 4 e to the 4. And so that is 9 over 4 times e to the fourth. And that is my slope. So my equation of my tangent line looks like y equals 9/4 e to the fourth times x plus b. Okay. And I have to remember I was given one more piece of information, which is that the point here that this is passing through is 4, 3 e to the fourth. Okay. Which I'm going to plug into this equation. Now, please note, this 3e to the fourth, if I'd not given it to you, you could have found it yourself, because this 3e to the fourth, this is just k of 4. That is, if I took the original function and I put in 4, it's what I would get out. So sometimes I give you this y-coordinate, sometimes I don't. Okay, so let's plug this in. So I get 3e to the fourth equals 9/4 times e to the fourth times 4 plus b. So 3e to the fourth equals 9e to the fourth plus b. So b, therefore, is minus 6e to the fourth. So the equation of my tangent line is y equals 9/4 e to the fourth x minus 6 e to the fourth. Questions about that, or other questions? Other types of questions? Other things you're wondering about? One C from worksheet 3, just to complete the triple. 1C from worksheet 3. Which is use linear approximation to approximate the square root of 27. Okay, so first things first, we need to identify that this is a value of the function square root of x. And it is a value of the function square root of x very near the point f of 25 equals 5. Okay. Now, the reason why I chose this particular point is that 25 is pretty close to 27, but unlike 27, I know the square root of 25. Okay, so then f prime of x here is 1 over 2 root x. So f prime of 25 is 1 over twice the square root of 25, which is 1/10 or 0.1 up to you. I only, by the way, ever write anything in decimal when I'm talking about these linear approximation questions, and only if it's a super nice decimal. You certainly don't have to. If you want to write everything in fractions, that's just fine. But these linear approximation ones I have broadly worked out so that they're rigged so that the decimals work out relatively nicely. Okay, so again, I can picture my graph here. Looks something like this. I have my point here, which is 25.5. And at this point, the graph is changing at a rate, or rather I should say the output is changing at a rate of 0.1. So what that's telling us is that at this point, the change in output over the change in input is being fixed at 0.1. So that is, for every 1 unit, I change the input, I change the output by 0.1. Okay. So, in this particular instance, what am I changing the input by? Well, here I'm changing the input from 25 to 27. So here our change in input is 2. Okay. So what that means is that my change in output should be more or less 2 times this slope, which would be 0.2. Okay. And what that means is that we're going to estimate that the square root of 27 is going to be about 5.2. Now, if you enjoy as much as I do the part where we compare that to the actual value, the actual square root is something like 5.196. So we were within 4 thousandths of the answer. Any more questions about linear approximation? I know linear approximation is sort of the one new thing on this test that was not in 140, which is why I did it the very first day. But if you have more questions about it, I am happy to talk about it more. Or any other questions you have, anything else you want to talk about. You should have a very, very good idea of what this test is going to look like. It should be in no way a surprise what any of the questions are. They should all look very much like questions from the homework/worksheets. And probably it's going well if when you're doing the worksheets to practice, you're already thinking to yourself, like, boy, didn't I already do this question on the homework? Because this is like almost exactly the same as this question or whatever. There's just that many types of questions that can be asked at this point. So you've sort of got the whole rotation of all of the kinds of questions I can ask in various flavors available to you as study aids. Your note sheet can be whatever you want. So if you want to include a worked example, if that's what works best for you, go right ahead. If you want to include a picture of your favorite Pokemon, go right ahead. But certainly there is an art that you'll get better at what things are most useful to have on your one sheet. Uh, because if you just try and cram as much as possible onto your sheet, you may actually slow yourself down if you're hunting all over the sheet for the thing. So you'll figure out what works for you, but it is between you and the sheet of paper what you put on the sheet of paper. Any other questions about anything? So again, on Monday, I'm going to have the tests ready at the front of the room, probably by 2:40. If you want to come by and grab a test from the front of the room and then go scope out your favorite place to sit, you can sit in your seat in the lecture hall if you like. You can sit in the hall if you like. There's a bunch of benches. On the second floor, there's a bunch of study corrals. On the third floor, there's more benches, more chairs, some tables. If you want any of those places to take your exam, you can go scope it out. Just grab the exam from the front. Then when you're done the exam, you'll just put it in the now hopefully very familiar box, which will be sitting up at the front of the room. I'll sort of peruse the halls in the room in case there's any questions. I don't think there should be any questions, but if there's anything that is unclear or whatever. So grab your favorite space, and then you can be on your way. And again, if you like the lecture hall, by all means stay there. But if you'd rather be somewhere more open for COVID reasons or whatever, by all means do that too. Once you're done with the test, just like with the quizzes, take pictures of it and submit it to Katie before you turn it into the box. Okay, I'll give you just another minute. If there's no more questions, then we can wrap up. Be sure you do have an excellent weekend. I wish I could say it should be nice, but it's not supposed to get above 0 until Tuesday, so I don't think I can say that. But enjoy your indoor activity of choice, I suppose I should say. All right, but with that, I'll see you on Monday. Have a great weekend.